Oh, hello. Mr. Dresser back again for some more IM2 with a mirror and a tape measure because we're going to go outside today. So normally if you guys were here on campus, we would put you in groups of 4 and we'd have you go do this task with your group. But today you're going to join my group and my son Calvin's going to be in our group and we're going to go measure some things outside around campus. We're going to figure out how tall some items are that otherwise we wouldn't be able to measure. But we can because we know how to use a mirror and a tape measure. So the first way that we're going to use indirect measurement is using shadows. So what will our diagram look like? Well, we're going to find something that's tall. Maybe it's going to be the flagpole. All right, it's going to depend on where our shadows are right now. But anyway, we're going to measure something that's pretty tall, and it is going to cast a shadow. All right, and so the shadow ends somewhere. If I connect this to the top, we then have a triangle. Well, because the sun's rays are parallel, if we're doing this at the same time, I am then going to measure my son or myself, we'll see, and we will also be casting a shadow. And then we can make this a triangle. And so because the sun's rays are coming in at the same angle, this angle and this angle here will be the same. And then because we're going to stand straight up and the flagpole is straight up and down, we'll get a 90-degree angle. And so we will have 2 triangles that are similar and we will be able to come up with a proportion. Now when we're out there, what will we actually physically measure, right? It's going to be hard for me to make this go all the way up to the flagpole. So I'm not going to measure that. That's what we're going to calculate. But could we put the tape measure at the bottom of the flagpole and measure how far it is to the end of the shadow? Absolutely. So I'm going to put a check there. We're going to measure that. Can we measure the height of myself or my son? Yeah, we can measure that, right? So we're going to find that. Can we measure the length of our shadow? Again, yeah, we'll take the tape measure, put it on the ground. We can find those things. So we're going to find the length of both shadows using the tape measure. We're going to identify the height using the tape measure, or we already know how tall we are. But to find the height of the tall object, we are going to use similar triangles or proportions. Okay, but what if there are no shadows? What if we go outside and the shadows are gone? Or it's overcast, or it's nighttime? Well, that's when we can use a mirror. So we're going to go ahead and do this one as well. And the way this is going to work is we're going to set the mirror down on the ground between us and the item we're measuring. So if we're measuring, let's say we're measuring one of those big light posts, right? By the quad, there's this light post. It's got a bunch of lights coming off it. Yeah, that's not really what it looks like, but you'll see it in a minute. So we're going to measure this. We're going to set the mirror down on the ground. So let me draw the ground. All right, this will be my mirror. I'm going to put the mirror on the ground. Okay, so that's going to be in between us and the light post. And then I'm going to move just to the right spot so that when I look down at the mirror reflects perfectly to the very top of the light post. So when I'm staring into the mirror, of all the things I could possibly see, I'm going to see the top of the light post in the mirror. So if I don't see the top of the light post, I'm going to have to either move backwards or forwards or left or right until I'm just in line to be able to see the top of the light post. Because if I get in the right spot, this angle of incidence and this angle of reflection will be the same. So we end up with the law of reflection. So there's one pair of angles. And then we have our perpendicular angles, so we have 90-degree angles, which means these are similar by angle, so we can find the height of the light post. Now, what am I going to physically measure? Well, I'm not going to climb the light post, right? So that's what we're going to use the similar triangles to find. But just like we did with the shadows, we can definitely put our tape measure down and measure from the base of the light to the mirror. So we're going to find the distance from here. All right, we can find that. And then we're going to do the same thing. We're going to see how far is it from the mirror to the person's feet. We're going to find that. And then we're going to measure the height of the person. However, we're not going to measure how tall the person is. We're going to measure to their eyes. Why would we measure to their eyeballs? Well, that's right. That's what's actually looking into the mirror. So we want to measure it from the eye height. So those are the three things that we will find. And then we will use our similar triangles to find the height. Let's go! Okay, so now we're outside and you can see my son standing there. Go ahead and scoot back a little, son. And you can see that he's got a shadow, right? You see the shadow on the ground. And then we've got this lamp post here, or not a lamp post, it's actually a banner, right? We got a banner on there, kind of like a flagpole of sorts. And it is also casting a shadow. You can see the shadow there on the ground. And because the sun's rays are going at the same angles, and because the banner is straight up and down, and my son is going to stand straight up and down, the height of each of them and their shadows will be proportionate, which means we can use similar triangles to solve this. So let's go measure. All right, so we went outside, we measured. My son was 5 feet tall. His shadow was 4 feet long. The shadow of the banner was 12 feet long. How tall is the post with the banner? Well, these numbers turned out super easy, right? We can see the scale factor to go from 4 to 12 is 3. So if he's 5 feet tall, we would multiply that by 3, and we get a banner height of 15 feet. Or we could do our proportion. And I set the proportion up as height over shadow length of Calvin equals height over shadow length of the post. Cross multiply. And I get 5 times 12 is 60. 4 times x is 4x. Divide by 4. And I get 15 feet. So the height of the flagpole was 15 feet. All right, or the banner post. Let's do another. All right, so now we're going to measure the height of this light structure behind me. If you've never noticed it, it's right by the quad, right? There's the quad, or the little theater up there. So we're going to measure how tall that is. The problem is the shadow for it isn't there right now because it's going the other direction, and that side is not level. So we got to come up with a different strategy. So we did. So you can see my son standing there, and right in front of him, you probably see that pink mirror on the ground. So what we did was we measured 25 feet to get to the mirror, and then I had Calvin move to just the right spot so that when he looks into the mirror, his reflection sees the top of that post. So I'm going to go take some measurements. All right, so here's the diagram that I came up with for the light structure. The things that we measured that the distance from the base of the light structure to the mirror was 25 feet. And then we measured that the distance from Calvin to the mirror was 3.5 feet. And then Calvin's eye height was no longer 5 feet, it was actually 4.5 feet. The kid has a big forehead. That's okay. All right, so we can use this to now find the height of the light structure. And why don't you go ahead and calculate that out? How tall is that light structure? Okay, well, one of the ways you could set this up would be a proportion. he might have done 4.5 over 3.5. So the height of Calvin over the distance of his feet to the mirror. And so we would match that up with the height of the light structure over the distance from the light structure to the mirror, which was 25. And then we can go ahead and cross multiply and solve. All right, so when I went ahead and cross multiplied and solved, I got 112.5 divided by 3.5, which was 32 we'll round it 1 feet. Now that does not mean 32 feet 1 inches, because 0.1 is not 1 inch, right? There's 12 inches in a foot, but it's about 32.1 feet. All right. All right, so when Calvin did this, he stood about 3.5 feet away, right? But when I'm standing 3.5 feet away and I look in the mirror, I don't see the top of the flagpole. Which way am I gonna have to move? Do I need to get closer to the mirror or further from the mirror in order to see the top? Well, in order for me to see the top, because I'm taller than Calvin, the distance from me to the mirror will also need to be greater. So I actually need to move back right to here. And now when I look in the mirror, I can see the top, and my proportions will be different than Calvin. My measurements will be different than Calvin's, but our scale factors will be the same. So we should still get that the height of the light post is about 32.1 feet. All right, so hopefully you're doing okay with how we can use indirect measurement to find the heights of various objects. Just want to do one last example, get you a little bit of extra practice. So we're going to use the mirror method, right? There's a mirror, to find the height of the Washington Monument in Washington, D.C. So maybe you've seen this monument before. And so when we went to Washington, D.C., we calculated the distance from us to the mirror, and then the distance of the mirror from the base of the monument, and then we calculated the eye height of us, of this guy, and with that information we're able to calculate the height of the Washington Monument. Now, is it going to be a perfect measurement? Probably not, right? If your mirror's not perfectly level, or the ground's not perfectly level, or you don't get to the exact right spot, we'll be off by a little bit, but it'll be pretty close. It's a good estimate. So, the distance from the mirror to our feet was 3 feet. The eye height of this particular person was 5 feet. And the distance from the mirror to the base of the monument was 333 feet. That's a long way to measure with the tape measure. But anyway, based on these measurements, how tall is the Washington Monument? All right, well, if we did it right, we should have gotten 555 feet. So we could do height over ground distance to mirror equals the height of the monument over the ground distance here. Cross multiply, 3x equals 5 times 333, which is 1,665. Divide that by 3, and we get that x, or the height of the Washington Monument, is 555 feet. Anyway, we could also do this using shadows, right? But hopefully you guys are doing okay with these word problems, and we will do lots more in class. So have a great rest of your day.